All right, we've been talking about linear equations and all kinds of linear functions. Now we're going to talk about special functions. There's a couple special functions that they're linear, but then they're not linear, and you'll see what I'm talking about here in a minute. One of these special functions is step function, and it's a graph of a series of line segments that, guess what they look like?
Lines. Segments. Line segments. Nope.
Steps. That's why it's called step function. All right? It looks like steps. So you know what it's going to look like. And so then all you got to do is you got to figure out the numbers and make it aligned right. But because each part is linear, this type of function is what we call a piecewise linear function, because its piece of it is linear, right? And you'll see what we're talking about. But linear means it's a line. So all right, so you need to write this down. One example of a step function is this, and it's the greatest integer function, which is written as f of x is equal to this, okay? Which bracket x with the two brackets on each side. That's what, when you see this, it's the greatest integer is what they're asking for. Okay, it's just like when you saw two big long lines, that's the absolute value, which you'll see again here in a minute. But when you see two brackets like this, that means they're asking for the greatest integer, which what that means is where f of x is the greatest integer not greater than x. Now we're going to graph that, but what I've done is I've just gave you a couple numbers just so you can see what you get. This is the asking for the greatest integer of 6.8. So what is the greatest integer? Which integers are like 0, 1, 2, 3, 4, 5, and -1, and -2, and -10. They don't have decimals. They don't have fractions. They're whole numbers, but also negative numbers. So what is the greatest integer closest to 6.8 that's not bigger than 6.8? Well, it'd be 6, right? Which, once we graph it, it'll kind of make more sense. But 6.8, the greatest integer next to 6.8 that's not bigger than 6.8 is 6.
Oh, I get that.
Okay?
I was really confused.
-2.5, the greatest integer of -2.5 is -3. Because -2 would be bigger than -2.5, right?
Yes.
Right? Because when you're working with negatives,
One is
the smaller number, like -1, is the biggest negative number, right? So -2 would be too big. So you go backwards. Like if you had it on a number line, I think that's kind of easier when you think about it. Here is, well, let's do 6 and 7 here. This is 6.8. Well, if I'm wanting the greatest integer that's not bigger than 6.8, right, then what would be the closest integer to it? 6. So if we did a number line here with -2 and -3, and I put a dot at -2.5, what would be the biggest integer that's not bigger than this? -3. Does that make sense?
Yes.
So everything includes it. So it goes to here, and you're going to see it better when we get to it on an actual graph. But here's what it's going to look like. It's a closed dot at 6, and then it's an open circle at 7. Because an open circle doesn't include 7. It's everything close to 7. So it could be like 6.99999. It's just not 7. So everything that's on this line goes back to this 6. Does that make sense?
Yes.
Okay. So we're asked to graph it, which you don't have to graph it unless you just want to. This is the parent function of the greatest integer function. It's f of x is the greatest integer value of x. And this is what it looks like. Right? And you can see, what do these look like? What do these line segments look like? Steps. Right? And so it looks exactly like what we were talking about, where you have a closed circle around 1 and then an open circle around 2. So so you pick a number. Let's just say I have like a table, and I pick a number. Let's say I go with Oh, let's go 5. Okay? 5, what is the greatest integer of 5?
4. 4.
Not bigger than 5.
Not bigger than 5.
4.
4 to 9, 9, 9.
4 to
Oh,
4.
can't be decimal, can't be fraction.
So,
It would be 5, wouldn't it?
oh,
Why?
guys, feel
The
stupid.
greatest integer of 5.
That was so obvious.
Why
5.
are we not doing the greatest integer?
Well, let me show you. Greatest integer of 5 would be 5. What if I did 5.2?
Then it'd be 5, right?
Then it'd be 5. Well, if it's 5.8, 9,
5.
5, right? So, and you can see that on the graph. 5, when I plug in 5 for x, I get 5 for the y, right? When I plug in 5.5, what is my y? 5. See? See how that works?
Yeah.
Okay? As long as I don't get past 6, like as long as I can do 5.99999, okay, which would be like right beside 6, what is going to be my y coordinate? 5. So that's why it's on this line. Now once I get to 6, what does my y coordinate become? 6. See how it works? See how each one jumps up? So at 1, okay, it's 1. But at 2, it's at 2. 2.99, it's at 2. But when I get to 3, it becomes 3. See how that looks? Okay. Now domain and range, when I ask you for domain and range, domain is just asking all the x coordinates. And I've talked to you before. So x coordinates, are there any x coordinates that's being limited, like I can't have? No, like as it continues right, it continues left. So my domain is called all real numbers. Because no matter what, like I can put in any x I want, right? I can put in 1,000, I can put in 100,000. My range, okay, that's the y coordinates. What will be my y coordinates here? Am I limited on y coordinates?
Yes.
I am. I'm limited to what? You guys, can you think? What am I limited to on y's? What's the only thing you see for y's? Not positive, because I've got -2, I've got -3.
It's negative 10 to
Okay? No, like, because it continues on. I just stopped. Okay? It continues on this way and that way.
You're limited to the domain.
I'm not limited to the domain. What I'm limited to is I'm limited to just integers.
You can't go to like decimal.
Why?
I can't go to decimals
Oh,
because it's the greatest integer function. Right?
dang it. This is.
So, because what this means, because remember, and I've told you guys this before, f of x I can replace with y. So y is equal to the greatest integer of x. So x can be anything, right? It could be 2, it could be 3, but it could be 3.3, it could be 3.14444. It could be anything. But what's my y always going to be? It's going to be an integer.
Right.
It's going to be a whole number if it's positive, but integers are negative numbers, right? And whole numbers. So it's always going to be an integer. No matter what my x is, it's always going to be an integer, right? And you can see that. Okay? Here, my x, this is -2.5. But is my y, what's my y? -3. Right?
Oh, okay, yeah.
Right? What we showed. So no matter what my x is, because I'm not limited, I can pick any number on this row. But I can't, which you don't pick y's, you only pick x's. So if I pick like an x, right, it doesn't matter, that's fine. Because my domain is all real numbers. Any number I want to pick, I can. But on this function, on this graph, what am I always going to have for my range? Integers. Okay, because this is an integer, that's an integer, -2 is an integer, -1 is an integer, 1, 2, 3, 4, 5. Okay, I'm never going to have 2.2 as a y coordinate because I can't, because I'm finding the greatest integer. Does that make sense?
Yep.
All right, so this is what that looks like. Now they could change it. They could do, which we'll see. Yeah, right here. Okay. All right, so you're going to be asked to graph a couple things. So you're asked to graph the greatest integer function of x plus 2. And then you're supposed to state the domain range, so don't forget to do that. Right? But we know what the parent function looks like. That's why we drew it. Okay? And you can see what it looks like. Now what you got to do is figure out what adding 2 to it does. And then the easiest thing to do is to make a table like here, figure out what adding 2 to it does, just do a few numbers. You don't have to do all the numbers. But I picked some numbers here just so you can see what happens and what the original would be versus what it is now, just to get you started. Because once you do 2 or 3 steps, you see a pattern very quickly.
So
right?
It doesn't matter what numbers.
Oh, it doesn't matter. I pick easy numbers to work with. Okay? So let's go with 0. If x is 0, what's x plus 2?
2.
Okay? So what would be the greatest integer of x plus or of 2?
2.
2. If I went with 0.5, what would be 0.5 plus 2?
2.5.
What is the greatest integer of 2.5?
2.
2. All right, so now we can see for x, for 0, it's going to be 2. On the parent function, if you look, when you plugged in 0, you got what? You got 0, right? Right? So when you're adding 2, now it moves it over to 1. What would be 1 plus 2? 3. What's the greatest integer of 3?
3.
1.25.
3.25.
3.25. But what's your greatest integer?
3.
3.
So it's like
So it doesn't matter what the decimal is, you're always going to revert back to that smallest integer, right? 2 plus 2 would be
4.
4. So what's the greatest integer of that?
4.
4. And 2.75 plus 2 would give you 4.75. But it reverts back to 4. See how it always goes back. So it doesn't matter what decimal are, it goes back to that greatest integer. So now I can use that to get me started. So I go to 0 on the x right here. Right? And what's my y? What does it say the y is? What's the y? Or what would this be? Okay? Because remember, f of x I can always replace with y if you forget. So what would be 0 for x? What would that give me? 2. So I put a closed dot at 2 because that's what's included. Alright? And when I went 0.5, I still got what?
2.
2. So no matter how far so as long as I don't go to 1, I stay at 2. So I'm going to put an open circle around 1, and then I draw a line connecting those 2 dots. Because at 0.5 or 0.75, I still get 2 as my y. Make sense? Now, once we skip to 1, what did my y become? 3. So I put a closed dot right there. Because 3 is included. And then, no matter what we get to, as long as we don't go to 2, what's my y coordinate? Like if I went 1.25, we got to what?
1.
No, what's the y coordinate? 3. Right? If I got to 1.99, I would still have a y coordinate of 3. So I put a open dot around 2, and I connect the dots.
So you're just steadily making.
Yes, and I just keep making this little step. Okay. But let's use the last one. We went with 2. What would be my y coordinate? 4. So I put a closed dot at 4. And so it's an open dot all the way, like it's an open dot at 3 and then a line in between.
But it doesn't matter.
Because, well, it doesn't matter. 2.75 was my y. What's the y of 2.75? 4. Right? So it stays, and see how you can see, like here to here stays here. Right? The y coordinate doesn't change. But once you get to 3, now what does it become? 5. See how it goes up to? Okay, which that's a closed dot. And then the open dot. And then we do it here.
You just keep on going.
You keep on doing it. Okay, I'm not going to, when we do this on your homework, I'm not going to expect you to do it 1,000 times. Okay, just a few, one direction. And then let's go backwards. Let's go the other direction. So what would be at 1 on the y? Would it be a closed circle or open circle?
Open.
Open. And then a closed circle at,
1, -1.
okay, at -1, 1, right? Right there. And then an open circle at -1 on the x, and then a closed circle at -2.
And then
Open circle underneath with a closed circle beside it.
and all the black and then all the solid dots are.
They include that number. Closed circles include the number, and we showed you here, 0, okay, became 2 on the y, right? Right, so we include that number, and here you have a closed circle. And if I put like 0.0999 or 0.99999, right, I don't, as long as I don't go to 2, right, then I'm still here, right? Once I go to the next number, it's an open circle, okay? That's why I get that open circle, because an open circle doesn't include that number. It's like everything that's less than or greater than that number, as long as it's not equal to that number. So it could be, like this circle shows that it could be 0.9999999, right?
Yeah.
Is included, but is 1 included? No. That's why it's an open circle. Once it's at 1, now it goes up, doesn't it?
Oh, yeah.
See, it goes up a step. Once you go to the next integer, it goes up a step.
Okay, yeah.
Okay? So each integer makes it go up a step. And so you do it 5 or 6 times each direction, I'm happy with that. Does that make sense? Okay. My domain, okay, it's all real numbers. And it's going to be that way. Greatest integer functions are going to be that way. And you can see, because each x coordinate is covered, whether it's 0 or 0.5 or 0.75, okay, they all overlap. At 1, it's not here it's not included, but here it is. So each x coordinate is included. That's what's, it's all real numbers. What about my range? Okay. It would be what? Integers. I didn't hear you. Sorry. I thought. So, all integers would be your domain. Now, some of these questions might just ask you what's happening to the graph. What's happening to the graph when you added 2 on the inside? You guys notice what happened to it?
Going up.
Well, yeah, but what happened compared to the parent function, like the original that we looked at?
It's added by,
Okay. The parent function, 0 was at 0, 1 was at 1, 2 was at 2, right? So actually adding 2 actually moves it to the left 2. Right? Because 2, the parent function was at 2, 2. This function's at 0, 2. Make sense? The parent function was at 3, 3. This function's at 1, 3. See how everything got moved back left 2 places?
When would you not get all real numbers and integers?
For greatest integer function, you're always going to get all real numbers for a domain and integers. Oh, I'm going to show you problems here later where your integers are something else, or your range is something else. Domain today is, if I remember right, it's all real numbers for everything. Okay. Later on, I'll show you where domain is not always all real numbers, but right now, most of the time, it's going to be all real numbers.
And you're grading against both.
All right, absolute value function. This is the parent function. This is what it looks like on a graph. Right? The absolute value, what it's asking for is f of x is the absolute value of x. And here's actually, we're going to talk about it later, but this is called piecewise. It's pieces of a graph. Okay? They have different sets. Like if x, which here's the different rules. Like if x is greater than 0, like if x is positive, then your answer is x. So if like 2, let's say 2, I picked 2, right? Is 2 greater than 0? Yes. So my y coordinate would be 2. 3 would be 3. 4 would be 4. 5, 5. And you can see it as it's going up, right?
Yeah.
When I get to 0, right? If x is 0, then my answer is 0.
So.
But if x is negative, like negative 1, then I do the negative x. Which, what's negative 1? Positive 1, right? Right? Negative 2, what's negative 2? Positive 2. Because really, what does absolute value? Absolute value just gets rid of the negative sign, right? We've talked about that. Absolute value is asking the distance that number is from 0 on a number line, and remember that distance can't be negative. So anytime you plug in a negative number here, you're going to get a positive number. So this is what it looks like. So when I plug in negative 1, I get 1. I plug in negative 2, I get 2. I plug in negative 3, I get 3. And it just goes up in both directions. So it's a V. It's a wide V. My domain would be what?
Integers.
All positive numbers.
All real? No, it'd be all real numbers. My domain's x coordinates, right?
Oh yeah, because
So,
if you go left,
I can go left, I can go right. It doesn't matter what number I plug in, it works. So all real numbers. But no matter what I plug in for x, my range is always going to be what?
Integers.
Not integers, okay? Because look, if I plug in, let's say I plug in 0.5. What's the absolute value of 0.5? 0.5, right? So is that an integer? Is 0.5 an integer? No.
Absolutely.
All real numbers.
You said it a minute ago.
No, all numbers.
No, all numbers.
All real.
You said it first.
All negative.
No, the opposite of that.
All positive.
You said all positive numbers. The domain is all positive numbers. They actually call it non-negative real numbers, but I don't care if you're at positive numbers. But they write all non-negative numbers.
Non-negative?
Yeah. All non-negative
Why do they have to be so picky?
numbers. That's just how they write it. Because 0 is not really positive, it's not really negative either. So they're saying non-negative instead of saying positive. So it wants us to graph f of x, which is the absolute value of x minus 4, and then don't forget you're supposed to state the domain and range. All right? Now what we're doing now, we know the parent function look like that. Right? So really what our goal is to figure out how it's different. Because then you can just fill in the rest. You know exactly what it's supposed to look like. So what I do is I just pick some numbers. Okay? I pick some easy numbers to work with. Let's go like negative 2, 0, 2, 4. Let's pick something like, I'm going to keep on going. Just go 5. Let's go 7. Some numbers like that. Just some numbers that's going to give me an idea of what's going on. Now, because I've done this so often, I know to pick certain numbers, right? I told you to just pick some random numbers, but these aren't random. I've done this on purpose, and you'll see why here in a minute. Okay? Because there's certain things I'm looking for. When I'm trying to graph this, there's certain things I'm looking for. One is I'm looking for where the V starts. On the parent function, the V started here at 0, 0, right? This is what we call a vertex, like the corner, it's a vertex, the vertices. Okay, this is the vertex. What I'm trying to do with this is find that vertex. So I've plugged in numbers that's going to show it to me eventually. Okay, so negative 2. What's negative 2 minus 4? Negative 6. Good, thank you, class. What's the absolute value of negative 6? 6. What's 0 minus 4?
4.
Negative 4. What's the absolute value of negative 4? 4. Tell Zach to come in. 2 minus 4 will be what? Negative 2. What's the absolute value of negative 2? 2. Yeah, there's a trend here going on. Okay. What is 4 minus 4?
4 minus 4 would be 0.
0. What's the absolute value of 0? 0. Plug in 5. What's 5 minus 4?
1.
What's the absolute value of 1?
1.
7 minus 4 is 3. What's the absolute value of 3?
3.
Are we seeing a pattern here?
No.
Okay. there should be a trend. The closer I got to 4, the smaller my number got. Because at -2 was at 6. Right? At 0, it was at 4. At 2, it was at 2. And then at 4 is 0. So that's my vertex. Because I can see on the other side of 4, 5, it started going back up. 7 was at 3. Right? Which I put that at the wrong spot. This dot shouldn't be there. It should be there. Okay, and then 6 would have been 2. If you plugged in 8, you would have got 4. And you can see when you're going to the right, when x is getting bigger, it's getting smaller. And then once you get past 4, now it becomes larger again. And that's what that looks like. What would be my domain for this? Okay, all real numbers.
Snap, just in time.
What would be my range for this? What would the y coordinates be? Say again, Richard.
All positive numbers.
It's all positive numbers. Well, what I would write is y is greater than or equal to 0. Because the y gets down to 0, but does it ever go below 0 on the y-axis? No, the smallest y, the smallest range would be 0. So I write y is greater than or equal to 0. It's any number that's bigger than 0 or 0. All right? Any questions on that? Now, it's something, I don't know if I pointed out Friday or not, but look at here, x minus 4. How is this compared to when it was just absolute value of x? Remember the parent function. This is what the parent function was here and here. How is this different?
Because it's moved over to
Right, it's moved over 4 to the right. Now, this isn't really necessary for you to know right now, but I'm kind of giving you this so later on, especially in Algebra 2 and trig and calculus, this comes into play a lot. Here, this is x minus 4. Okay? Subtracting 4 actually moved the diagram which way?
right.
To the right. Subtracting 4 inside moved it 4 to the right. If I wrote plus 4, which way do you think it would have went? It would have went left. It's kind of the opposite of what you think. Which actually you could see that when we did the step functions, we added 2. But which way did it go? Which way would we determine it moved? It moved left 2, right? So when it's inside the operation, adding 2 would move it to the left, subtracting 2 would move it to the right. So it's the opposite of what you think. Now, if you add, like let's say I got like right out here, it'd say plus 4. What do you think that would do to it if it's on the outside of the operation? Right? If it's on the outside of the operation, here it's on the inside. If like minus 4 would be here, it would actually move it down 4. If I wrote plus 4 here, it would move it up 4. So on the inside, it moves it left or right. On the outside, it moves it up or down. Now again, this really doesn't matter too much because we don't spend a lot of time on it, but you're going to see a lot of these later with Algebra 2 when you're talking about like exponential graphs and that type of stuff. Right? If it's on the inside, it moves it to the left or right. If it's on the outside, it moves up and down. Now, again, here, negative moved it to the right. Positive made it move to the left. So the opposite. Moving up or down is actually what you'd think it'd be. Plus 4 would move it up, and minus 4 would move it down. Now, there's another way. There's something else that they can do to this. Right? Instead of this, you can tell is 1 by 1 by 1. Up 1. Over 1, up 1, over 1, or it should be. Okay, and the parent function is like that. It goes up 1, over 1 every time. If you times it by 2, it actually, if I remember right, it makes it steeper. So it would be like this, where it's up 2 over 1. So multiply it by a whole number actually makes it steeper, makes it like that, where it have a steeper slope. If timesing it by like a half, would actually make this not as steep. It would be up 1 over 2, so it wouldn't be as steep as this. So there's several different things they do to graphs. And again, this is more for Algebra 2, where if they multiply something, it changes what it does. It changes if it opens up wider or if it's steeper. And then adding or subtracting moves it to the right or left or up or down. It just depends on where that operation occurs. So that's just something for later. See if you remember that in a couple years. If you do, come back and tell me. All right, write this down. Now, this is another type of graph, but it actually is just like an absolute value. Absolute value graph is a piecewise defined function because pieces of it have certain rules, and then other pieces of it have different rules. When we talked about absolute value, if the x was positive, then it was just x, whatever it was, and so it looked like this. Now, when x was negative, right, we had to change it to a positive number. We had to change our y to a positive number so it could look like that. This is the same thing, except it's not absolute value. They just define certain pieces, right? This says graph of x, and it says if x is greater than 1, then you graph this, which is y equals negative 2x. If x is less than or equal to 1, then you would graph x plus 3. So it's two different lines, two different graphs, and it just depends on what your x is, depending on which graph you're going to use. So let's draw this. Let's just pick a number, okay? Let's just pick some on the right of 1. So x says if x is greater than 1, you need to graph negative 2x. So let's go with 1, okay? Actually, let's do the other one just because it's easier. X is including 1 on this bottom one. So let's graph x plus 3. So if x is 1, what would be y? What's 1 plus 3? 4. So 1, 4. Okay, and it's going to be a closed dot. That's going to come into play later. If x is less than 1, so let's say 0. What's 0 plus 3? 3. Let's say it's negative 1. Negative 1 plus 3 would be 2. Negative 2 plus 3 would be 1. Negative 3. Negative 3 plus 3 would be 0. Right? And so you can already tell what x plus 3 looks like, right? Which we can keep on going down and putting dots if you want, or you can just make a graph. Right? So it's going that direction. Why didn't I not finish it? Why didn't I not draw that direction? Anyone know? Because if I kept on going in this direction, would I draw x plus 3? No, I would have to draw a negative 2x. Because x is now greater than 1. So let's pick a number that's greater than 1, which let's say 2, right? Is 2 bigger than 1? What's 2 times negative 2? So 2, negative 4. Let's pick 3. What's 3 times negative 2? Negative 6. And let's just pick one more. Let's say 5. Negative 2 times 5 would be negative 10. Okay? Now, the thing about this is, okay, we're going to actually go to 1. You're actually going to plug 1 into negative 2x. But it's not going to be closed circle. It's going to be open circle because x doesn't include 1. But we have to have a circle around it because it includes 1.1, right? Is that greater than 1? Yes, so I want an open circle around 1 because it's anything close to 1. So what would be 1 times negative 2? Negative 2. So I'm going to put an open circle around 1, negative 2. And then I'm going to close it. I'm going to finish it off. I'm going to draw my line going that direction. So this is what a piecewise defined function looks like. Because it's two different lines, okay, depending on what x is. If x is less than or equal to 1, then we're graphing x plus 3. If x is greater than 1, then it would be negative 2x. Right? And they use this type of stuff to graph certain things. And I just trying to think of examples where your cost of something might be this, and you can graph it, but then once it reaches a point, now your cost is something totally different. So they would graph it in a different direction. It would be graphed in a different line. So this would be this. This is what a piecewise define looks like. Right? It's defined using two or more expressions. What would be my domain? What's my domain here? What's my x coordinates? What's included? All of it. Again, domain in this case is all real numbers. What about my range?
Integers.
No, not integers. Because y, you could say y includes like 1.5. It includes 2.5, 2.3, that kind of deal. It even includes negative 4.5, right? So what would be my range here? No, because does the graph ever go above 4?
No.
Is 5 ever included? Is 6 ever included? Is 7 ever included? No. So here's what I would write. I would write y is everything less than or equal to, what do you think? 4. Because 4 is my greatest number on the y-axis. Would include everything going under 4. Right? 3, 2, 1, -1, -10, -100. We can see that this goes on this direction and this goes on. So either way, right, this is all going to be included. But it stops when we get to here. Does that make sense? So when it asks for domain and range, you're just looking at what's included. What do I know is always like going to be there, and what's not? What's excluded more is what you're asking, right? For the domain, your axis, nothing's excluded because this continues on. Yes, it's a steep slope, but really you could figure out what 100 is on the x-axis, right? I plug 100 in, it works. Plug in a -100, it works. -1,000, it works. But if you were trying to find a range of 5, you would never find it because this doesn't go past 4. So that's what it's asking for. What's included, what's excluded. All right. Now, you don't have to draw these unless you want to. This is just kind of a brief overview. These are the parent functions. This is what a step graph looks like, okay, which we saw, and this is, okay, it's, if you see it, it's f of x is the greatest integer function. Okay, that's the parent function. That's what it looks like. Everything else we do is going to be based off of that for our greatest integer function. Absolute value function is f of x is equal to the absolute value of x. That's the parent function of that. Everything else, everything they're going to make you graph is based off of that. It's either going to be moved to the right or left. It's either going to move up or down. Right? And then you've got piecewise defined function is the same thing, okay, where x at one point is the one line, and then like here, when x becomes 5 or 4.1 or 4.2, it becomes this line. Everything before it's on this line. So that's just two separate functions included in one. All right. Any questions about that? All right. Here's your assignment for today, which we're going to work on together. So I will pass out graph paper for everybody, and you are to get started.